Guys, some episode ago we talked about the basis of calculating and processing devices, right? So this episode we're going to be talking about calculating and processing devices part 2, and this part 2 we're going to be talking about a number of concepts which will be slightly advanced than the part 1 of this series, and I hope you enjoy this video. So first of all, we're going to be talking about the performance objective. So what do we expect to achieve today? So the first thing we expect to achieve is basically we expect to run through the number systems using computers. Now, number systems in computers, they are quite things that are very important. They are instrumental to understanding of the business of programming. So some days ago I was trying to understand computer programming, and then I had to go back to the concept of number systems because they are actually very important. They are instrumental and they are very indispensable if you are going to understand programming. You need to understand number systems because computers, they operate in bits and binaries. So that being said, let's delve into number systems themselves. So number systems are concepts that have to do with the different bases of numbers. So we have the base 10, base 2, base 3, base 4. So these are the different bases, and each of these bases, they have their own properties. They have their place values, they have their absolute values, they have their number of digits, and so on and so forth. So the number system is to the base p, where p is a positive integer. The system is a system consisting of the digits 0, 1, 2, 3, and so on and so forth, to p minus 2, p minus 1. In this chapter, we shall examine the number systems used in real life and computer. So the number systems we'll be considering today in this episode are: first, decimal systems, which is basically the one, it is the de facto system we use in our day-to-day lives. We count in base 10, and we are very used to it, that any single alteration of that customization, we kind of flip our heads upside down. So, and then we also have the binary systems, which is the one which is to which computers are customized, and just try to mess with that and try to change it from binary, and then your computer will mess with you. Then we also have the octal systems. We also have the hexadecimal system. So these are different number systems we're dealing with in this episode, and let's delve into this concept without much delay. So let's talk about the examples on this number system. Now this is basically mathematics, but it's a mathematics that is tied to computer systems. So let's talk about this expanding of decimal numbers. Now we calculate in decimals, right? So this shouldn't be an issue for us. So first of all, we have the number 7,342. We are trying to expand it into a we are expanding it into expanding notation, not into anything anyway. So basically, all you need to do is you look for the place value. So basically, the place value of 7 here is 3. So the place value of 3 is 2. Place value of 4 is 1. Place value of 2 is 0. So you basically put small digits on top of the numbers 0, 1 to 3, from 0 to 1 to 2 to 3, as you can see in the on the screen. So I've quite annotated it here. You have the 0. You can see the small 0 on top of the numbers. That is the that's what we call the place value. So I have 0, 1 to 3. I've written it in place value today. So 7 has a power of 3, right? So now when we expand it to be expanding into 7 times 3 raised by 3, then 3, we'll add that to the expansion of 3, which is 3 times 3 raised by 2. We'll also add that to the expansion of 4, which is 4 times 3 raised by 1, and then finally to the expansion of 2, which is 2 times 3 raised by 0. That is how to express any base, not just base 10, any base in the expansion of expanded form. But you will notice that we are expanding this to the power of that base. So notice we are saying 7 times 10 to the power of 3. Now if we're in base 9, we will say 7 times 9 to the power of 3. If we're in base 7, we'll say 7 times 7 to the power of 3. If you're in base 2, we'll say 7 times 2 to the power of 3. So your base is what you are is the base to which you are raising your place value of those digits in the base system. So I hope you understand that concept, and you'll be able to deal with that on your own if you are required to. So now let's talk about another concept which I did not get to learn in secondary school, and you getting to learn it will be something very awesome, and that's the concept of complements. So I want to talk about complements. Complements, they are quite it can be quite tricky to grasp, but the ninth complement of a number in base 10 is a number obtained by subtracting each digit of the number from 9. I remember when I first read it, it was quite like, what did you just say? Now let me repeat myself just in case you don't understand. The ninth complement of a number in base 10 is a number obtained by subtracting each digit of the number from 9. Now you can see in this example here, we are looking for the 9th complement of 2894 example. So you need to do, you subtract each digit from 9. That's in the first case, you have the first digit you can see, which is 2. So you subtract 2 from 9, which is 7, and then you write it in place of 2. Then you go to the next digit, which is 8. You subtract 8 from 9, which is 1. You write 1 in place of 8. Go to the next digit, which is 7. Subtract 7 from 9, which is 2. Write 2 in place of 7. Go to the last digit, which is 9. Subtract 9 from 9, which is 0, and write 9 in place of 9. That is the simple way of you looking for 9th complement. But you might be like, okay, what's the point? Why are we looking for 9th complement? Now the operation of subtraction can be converted to addition with the aid of 9th complement, and 9th complement can also be followed by, we also have 10th complement. So in this place we have 10th complement. So for the same way, the 10th complement of a number is obtained by adding 1 to the 9th complement, and the 9th complement and the complements of the following numbers are shown on the table. So for the 10th complement, you easily get it by just calculating the 9th complement and add 1 to the 9th complement to get the 10th complement. So in this case, if the 9th complement is 7120, the 10th complement will be 7121. So this is a question for you. If the 9th complement is 200, the 10th complement will be what? That's 21. You got it right. Yeah, clap for yourself. So basically, I know this is simple enough, so which is why we will not be doing much on that, but I hope you understand the basis of the decimal system. So let's move on to the octal system. Now the octal system is a concept which is going to be less likely to be understandable for you, but the octal system is quite simple, and it is something by which computers can also convert to, and because of that, I believe it will be quite easy for us to deal with. So the octal system, yeah, in the octal system we deal with different kind of concepts, which is quite instrumental to understanding the octal system. So in the octal system, it's a number system which we deal with numbers in base 8, and then the digits consist of 0, 1, 2, 3, 4, 5, 6, and 7. And any number x in base 8 can be written uniquely in the form x times h raised power n, and so on and so forth. So basically, when you are expanding this, you are expanding to the power of what? 8, just like we were expanding in the previous some moments ago. So expanding to the power of 8, and then from now on, the base of the number will be indicated by a small subscript. So for example, 240 subscript 8 is meaning that 240 is a number in the base of 8. So now this topic, I'm very sure that a lot of you are enjoying it, because I myself am also enjoying what I'm teaching. Like, this topic is quite simple, it's interesting, right? So let's move on to another concept here. Let's talk about something here, that is the hexadecimal system. Now the hexadecimal system is a system that is quite large in comparison, because you deal with large of numbers. You deal with 16 absolute values. As if that's not enough, they even added letters to the numbers, but you can do it, you can understand it, you got it. So now basically, a number system using 16 as its base is called the hexadecimal system, and then the digits ranges from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9 to A to B. You are thinking I will go to 10, right? No, from 9 to A, from A to B, C, D, and E, and F. So those are the different digits of the hexadecimal system. And I remember when I was teaching my students this concept, they were like, wow. Now when you are in the basis of mathematics in your primary school and your junior school, you might not deal with this kind of concept. I did not deal with it in my primary school, but I had a little bit of contact with them. But even at that, I did not do some intricate calculations. But it's just when I finished secondary school and I'm going for computer related course, which I decided to kind of brush through this concept, and I discovered that these are quite exciting concepts which are fundamental to computer science, and not just computer science but any part of mathematics. You deal with this basis, and this basis is good to know that we don't just have base 10, we have base 1, we have base to infinity, and we can decide to deal with any new things in there by calculations. I'm very sure there are different concepts that are still not popular in mathematics in other bases, because we are localized to base 10. So if we would think in other bases, there will definitely be more theorems we can release in mathematics. This is just a gesticulation on my part. So that was the concept of bases, and you will mostly be dealing with conversion from one base to another. And if you don't know how to do that, I've talked about that in mathematics course in this channel. So basically, that's the end of the concept we're dealing with today, and I hope you enjoyed this episode, you enjoyed this video. If you did, don't forget to like, share, and subscribe to this channel. and I hope to see you next episode. Good luck.